Hey everyone, this is Derek, and in this video we're going to look at compound interest formulas. So for compound interest, similar to simple interest, we're making a lump sum deposit at the beginning of this thing, and then at the end we're going to hopefully have more money than that in the account. But that's basically what 6-1 is about. So with these formulas, I'm going to use a little bit different notation in the book. You'll see I use this N and this I. As I do a problem, I'll show you what those are in context because it will make more sense. I think we have seen everything in here except now we have this M, which is a number of compounding periods per year. So for simple interest, it's just compounded once at the end. Now we can have quarterly, monthly, daily, semi-annual, annual. So we can have different number of compounding periods. So then we'll see that in this formula as well. Okay, so this one goes, what is the future value if $12,000 is invested for 4 years at 12% compounded annually? Okay, so what is the future value? So that means we are looking for the future value, and we're going to deposit 12 grand, so that's our principal or present value. And so when we get to the next section, our time is 4 years, and our rate is 12%. And so then back here, I have these two other quantities, and in this problem, they're not going to be very exciting. And the reason is it's compounded annually. So M is 1. So if I went to calculate this value N is the number of compounding periods times the number of years, MT. So it's just 4 times 1, and so it's the same 4 that we would have got plugging in T. And likewise, so the interest, since it's only compounded once per year, when we go to find the little I, it's the rate over 1 again. So it's the exact same thing as the rate. That will do something different on the next example. And then once we have all that, we're just going to basically plug it in the formula. We're looking for future value. So future value is going to equal 12,000. And then 1 plus I, which is 0.0 or 0.12, and then raised to the MT, which is N, which is 4. And now let's just chunk all that in a calculator, and I got 18,882.23. I did. Okay, this one goes, what lump sum should be deposited in an account that'll earn 9% compounded monthly to grow to that much in 21 years? So how much do we need to put in today? So that is principal or present value. So that's what we don't know. We know our rate is 9% compounded monthly. So that means the number of compounding periods per year would be 12. And this is how much money we want to have in the future. So that's our future value. And T is 21 years. So then we have those two calculated values. Remember, N equals MT. So now we have M is 12 and T is 21. So N is going to be 12 times 21, 252. So this is the total number of times it's going to be compounded over the life of this account. And then I is R over M. So this is going to give our interest per compounding period. So our rate is 0.09, and then compounding periods are 12. And that one, if you threw that in the calculator, 0.0075. So then we get to toss these in rather than try to type all that at once. You'll see the calculator gets a little bit messy on these. So plugging this into that formula, we'll have 92, 0.2. So that's our future value equals our principal. So that's what we're trying to work out. 1 plus I, so 0.0075. And then raised to the MT, which is this N, so 252. And then I just threw this in a calculator and then divided it into that. And I got the principal be $14,000. So we've seen simple interest and then different numbers of compounding periods. And basically what happens, so with simple interest, I should have said this back in that one, is say you make a deposit for $100 and you get 5%. So that means at the end of the year, you're going to get $5 in interest, right? So with simple interest, you actually take that $5 out and then you don't get interest on that money. So even if it's sat there for 3 years, that $5 is not part of the next calculation. So that's the difference between a compounded annually. So in that situation, if it was 3 years, put in $100, at the end of year one, we have 105. So then we're going to get 105, or we're going to get 5% on that $105. So we'll get a little bit of extra interest the second year and then again on the third year. So the idea of this is what happens if we just kind of kept letting those compounding periods go to infinity. So we could have once per year, quarterly, monthly, daily. So then the question is, does it approach a value? And it does, and that's where E is going to come in. So the way we can distinguish this formula from the other one is if we see the word continuous. So if we see continuous compounding, that's E. Anything with like a finite number of periods, that's the other one. And everything else is the same as what we've seen. So what is the compound interest if $150,000 is invested 7 years, 8% compounded continuously? So this one is worded a little bit, they're trying to mess with you right there. It's asking for the interest, not the future value. We're going to find the future value because we're going to use that to get interest. But we just have to be careful that we're not actually solving for the thing it asked for on this first step. So we're putting in 150 grand, E to the 8%, and then that's times 7 years. So then I threw that in a calculator and I got my future value to be 600.88. But it didn't ask for future value, it asked for what is the interest. So to do that, I would want to take, this is how much money I had in the account at the end. I put in 150,000, that was my money. And so the difference is the interest. And so that would be our interest.